In this guide, we will learn how to set up our local workstation to run and test challenges. We will fix a security bug, locally test it, and then push our changes to get a score for the challenge. We can run the challenges either in a container on our workstation or on your host, by which I mean your operating system, which can either be Windows, OS X, or Linux. In regards to Windows, we first need to set up an Ubuntu desktop virtual machine. You can find the guide on the Ubuntu site, which outlines how to run an Ubuntu desktop virtual machine using VirtualBox on Windows. Once you have set that up, we can continue. For Linux and OS X users, you don't need to do this, and you can follow along the instructions that are present in this guide. By running the challenges inside a container, all the required app dependencies are automatically given. However, if you decide to run the challenge on the host without the container, then you need to manually install those dependencies. They are given in the source code repository, and depending on the programming language, they differ. Now let's start the setup challenge. For C#, this is the setup.cs challenge. The understanding being that you have already finished the introduction.cs challenge. To run a challenge locally, we first need to set an SSH public key to our SecDim account. And we also need 3 commands: git, make, and docker. Git and make have already been provided by default in majority of Linux and OS X distributions. If you look at the bash script that you're given over here, this bash script will run a setup that will go through this entire process, including adding an SSH key to your account. So copy this bash script, open up your terminal, paste it, and execute it. Firstly, it will ask if you have already registered on SecDim. If you haven't, you can simply click on sign in and go through the registration process. Next, it will ask if you have already added your SSH public key. Normally, you will be told during the registration process on how to generate and set your SSH public key for your account. However, if you haven't added your SSH public key, you can press N and it will go through that process. If you have signed in using either GitHub or GitLab, you need to manually add your SSH public key. You can do so by simply going to your account settings, which you can find if you log into your account. Once there, you go to SSH key, add or update SSH key, where you'll find the basic instructions that allow you to generate your public SSH key. Otherwise, the bash script will do that for you. As you can see, the bash script generates your default SSH public key pair for you, but if you already have an existing one, it just uses that. Then it'll ask you for your SecDim username and password, which upon providing, it'll proceed to verify if the SSH connection works. Once that is done, it'll then proceed to install all the required tools. However, since I already have the required tools, it'll instantly check off everything. You can run this setup as many times as you want, since the script checks if you already have the tools or not. With this, my workstation is now ready to run challenges locally. Let's start the setup challenge. Click play, followed by let's do this. This will start the challenge, and you'll be greeted with a pop-out, which you can always find by clicking on the clone button later. This pop-out shows you the SSH link. You can click copy to copy the link, or press any of the buttons to open the code in your IDE of choice. Once you have copied it, head to terminal. You can do git clone followed by pasting the SSH that you're given. Hit enter, and since our SSH key is already set, we have successfully managed to clone the repository locally. Then you can open your code in your IDE of choice, which in my case is Visual Studio. As you can see, the files given to me on the Cloud IDE have now also been made available on my local workstation. A few simple commands to remember. To build this application locally using the container, you can do make build. This will build the container image. The container image contains all the dependencies which are required for us to run the app. The application will be readied for us as it goes through the entire build process. So as you can see, our container is now ready. Next, there is the command make test. Make test essentially fires off the usability tests for this. These usability tests, as mentioned in a previous challenge, they exist to make sure that the application is working as intended and has not broken. We expect the tests to pass. And would you look at that? The usability tests and functionality has passed as we expected. Over the course of our debugging and testing, it's important to know that we don't break the app. The next important command to remember is make security tests. This will run the security tests that we already have in this challenge. The security test tests the repository that you have for the security vulnerability of the challenge. If it exists, then as you can see, it fails, which is currently the case since we have not patched the security vulnerability ourselves. The last thing that we have to consider is the make run command. With make run, you will be able to run your application locally. As you can see, it says localhost 8080, which we can navigate to. And as this application is a simple web app that simply returns a parameter along with a hello. Now, before I dive into fixing this security bug, there's another command we should keep in mind. Every time we make changes to our application and save them, then every time we run the make test, it is going to apply our changes into the Docker container and, if necessary, rebuild the image before conducting the test. The same is done for security tests. This speeds up the debugging process for us since the image is rebuilt with your changes but reuses all of the files that haven't been changed. So your changes are applied directly. Another way of also applying or checking or testing your changes is via the make debug command. Make debug rebuilds your Docker if necessary and returns a shell. So you can run your commands directly inside the Docker instance over here. Another command that is worth noting is called the make push command. What this essentially does, which you can find if you head to the README, is it does git add of all of your changes, git commit with the message security fix, and git push. So essentially, it pushes all of the changes you made to your repository to your remote repository where the challenge is currently running. Now, doing make push will push all the changes of your code to the remote repository. This, as long as your auto test is enabled, will basically rebuild the Docker, run the usability test, push your changes. Once the usability tests have concluded, your changes will be pushed into a commit. And since we had auto test enabled, you can see that the tests kick off by themselves. A final pro tip is the make status command, which returns the status of your test along with your remaining time and any output that's made available into your terminal. This way you can track your progress without needing to switch to your browser. It is important to know that you need to have your browser page open for the server tests to kick in. As mentioned, if you have auto test enabled, doing make push will run the test by themselves. However, if you do make push and you do not have auto test enabled, your changes will be shown as a commit that you can run a server test on. It is important to have this window open in order to be able to run the server test, as without testing these commits through here, you will not be able to receive a grade for your challenge and consequently won't be able to pass. Now with that, let's dive into the program itself. In the application controller, which is essentially our main file for this program, we find that there is a function that essentially returns hello, root, root being the name parameter, which it receives as a query parameter. If we look at the usability tests for this, we can see that it is the same as before. However, the second test has changed slightly. It is expecting that the parameter name would have Alice, and by extension, the function in our main controller is going to return a result that contains Alice. So let's run and test it. Doing make run will run the program locally in your system. And here is a web application which opens on the port 5000. So I can use a new terminal to interact with it using curl. Or I can go into the browser and go to localhost 5000 to achieve the same effect. Now here, if I provide the query parameter name, we will observe that the web page is going to return whatever parameter I am going to send it. This is the time where you want to play around and think about what could possibly go wrong with this program. It is a common and trivial security bug right here. Anything I type in the parameter is effectively being called back. A normal user might enter names or numbers like this. A would-be hacker might enter something like this. As you can see, the JavaScript code alert got executed under the context of the HTML that we have. Without going into further detail, this is an example of a cross-site scripting attack, where an attacker can provide arbitrary JavaScript and maliciously exfiltrate the user's private cookies. Being able to provide arbitrary JavaScript provides a hacker with a lot of power against an unsuspecting user, through which they can get sensitive information. Our security test for this challenge effectively tests for that. So as you can see, instead of Alice, we have the script tag. One way to prevent cross-site scripting is to escape these dangerous HTML characters, which is what the security program expects us to do. Hence, when we run the security test right now, it is going to fail because we are not returning the expected escape characters. And would you look at that? The security test has failed as expected. There are a number of ways to fix this. We can write a simple mapping algorithm to map these values to their escape equivalent, which is HTML safe. Or we can go to the main code and implement something else. Using inbuilt functionality, we can instead sanitize the input. It is important to know that we can use inbuilt libraries and functionalities, but we are not allowed to import external libraries and functionality. The idea is that we need to solve the security vulnerability using our own code. Now, with this, we are essentially going to encode our parameter input into an HTML safe result. Now, if we run make test, we expect the security test to pass because we address the security vulnerability regarding the HTML encoding to make our characters type safe. And would you look at that? The security tests have passed successfully. Now, we can simply do make push in order to push our changes to the browser. As mentioned, it is important to keep the browser window open during this. Otherwise, the tests will not kick off on the server. Our app is going to run functionality test, which passed, and now we are greeted with a commit. By having auto test enabled, we can kick off the test immediately. And since we expect them to pass, the challenge should pass and we will be given a score. We can do make status on our terminal in order to get the result, which, as you can see, our tests have passed successfully because we were able to patch the security vulnerability. With that, the challenge has been won. We can also run this challenge without the container, which we can do so by going into the source directory and making sure we have all of these dependencies installed. And with those, we can essentially run our project locally without the need of the Docker. One last thing is the solution that we implemented to fix the cross-site scripting. This is known as output encoding. However, this patch is not recommended for enterprise coding, as there are more robust ways to code, especially in a larger code base. That is not discussed here, as this fix is just for the sake of the challenge, and the intention is just to give you a taste of fixing a security bug.